Welcome to this podcast on incremental benefit cost evaluation of two or more mutually exclusive alternatives. The techniques and procedures summarized here are essentially the same as those required to complete an incremental rate of return analysis. As with rate of return analysis of multiple alternatives, incremental analysis is required. The selection guideline is much the same. Choose the one alternative that has the largest incrementally justified cost, provided the base cost is also justified. The incremental BC ratio is called delta BC. When it is greater than or equal to 1, select the higher cost option. If not, select the lower cost alternative. Compared to ROR analysis, BC has two important differences. You are already aware of the first difference. It is the sign convention. All values carry a plus sign, including costs and disbenefits, so delta BC will be positive. Second, incremental analysis is based on equivalent total cost, not just the initial investment as used in incremental ROR evaluation. Before detailing the analysis procedure, let's cover some preliminary items. The annual worth AW equivalent value is usually applied. However, PW and FW, or future worth values, work equally well. The ordering of alternatives is based on total cost. This means that all costs, initial investment, and annual M&O costs are included when the equivalent value of cost is calculated for use in the denominator of the conventional BC ratio. Any expected salvage values are removed from the equivalent total costs. Equal service comparison is required for delta BC analysis, just like other methods. However, public projects commonly have long expected useful lives, so the lives or N values can be assumed to be equal. Therefore, this requirement is not a problem. Routinely, the conventional BC ratio is used. If disbenefits are estimate, the formula B minus D over C is applied. Alternatives must be compared in a pairwise incremental fashion, using equivalent forms of the B, D, and C estimates. If no alternative is incrementally justified, the do-nothing or DN alternative is the best economic choice. The benefits in an incremental BC evaluation are either estimated directly or in an implied manner. Direct benefits are estimated in a fashion similar to those for revenues in an ROR evaluation. Any overall BC ratio that is less than 1 means that the associated alternative can be eliminated without further evaluation. Implied benefits are based on the difference in usage costs. This commonly means that a less expensive alternative will have a higher usage cost than the next higher cost alternative. That is, the defender usage costs are larger than the challenger usage cost, which leads to the relation for estimating incremental benefits shown here. Delta B is equal to the defender usage minus the challenger's usage cost. As you may have noticed, the defender and challenger terminology is used for incremental BC comparisons. The defender D is the currently selected alternative, and the challenger C is the alternative selected if the incremental BC ratio indicates justification, that is, it is greater than or equal to 1. Now we are prepared to detail the steps of the incremental BC evaluation for two or more alternatives. There are a total of 7 steps. First, determine all equivalent total cost values. Use AW, PW, or FW equivalencies at the stated discount rate. We will assume that annual worth or AW values are used. Second, order the alternatives by increasing AW values. Next, each alternative's total equivalent annual worth of benefits and disbenefits, if they are included, are determined. As we shall see in the example that follows, for implied benefits, the incremental benefits, that is, delta B, is determined at this point. Much like the procedure for the rate of return method, when only costs are estimated, step 4 depends upon the types of benefits estimation, that is, implied or direct. If implied benefits are present, move on to step 5. If benefits are directly estimated, remove all alternatives that have a BC less than 1. They are not justified against the do-nothing alternative. Then it is time to set up the first incremental comparison of defender and challenger. The defender is the lowest cost justified alternative, and the challenger is the next lowest cost. Now the actual comparisons take place. Find the incremental benefit and incremental cost values between the first defender and challenger. Step 6 is a decision-making step. Calculate the incremental ratio, delta BC. Determine if it is less than 1 or greater than or equal to 1. If it is greater than or equal to 1, eliminate the first alternative, that is, the defender, and form the next comparison with a new challenger. However, if delta BC is less than 1, keep the current defender. Remove the current challenger now and identify the next challenger. For the last step, number 7, continue eliminating until one alternative remains. Select it as it is the best economically. It has the largest justified cost using the BC method, and it will be the same selection as that for other methods: annual worth, present worth, future worth, and rate of return method. This example compares 3 options for solar panel installation to supply power to a small factory building. The requirement of a backup generator is considered a disbenefit. The analysis is based on present worth values at a 5% discount rate. We have the present worth values of all initial costs. For example, option J has a first cost of $6.15 million. The estimated annual M&O costs are in the second row, and they will be combined with the present worth of the initial costs to obtain the equivalent total costs. Benefits are not directly estimated. Rather, the annual usage bills will be used to obtain the implied incremental benefits. In a similar fashion, the backup equivalent costs will determine the incremental disbenefits. The last row indicates that a 15-year study period is used as the expected life of all 3 alternatives. Here we start the incremental BC evaluation. First, determine the present worth of total costs using this relation. For example, in alternative G, the $500,000 M&O cost is brought back to the time zero with a PA factor, and it is added to the first cost of $2.4 million. The total PW value for each alternative is shown here. In step 2, we order the alternatives by increasing present worth value. The evaluation order is G, H, and finally J. H versus G will be the first comparison. It is important to recognize that although alternative H has a lower first cost than G, $1.85 million versus $2.4 million, H has a higher equivalent total cost, about $8.6 million versus about $7.6 million for G. This is why the incremental BC method requires ordering by total costs, not just first costs. Step 3 for implied benefits can be a little tricky in that the result is incremental benefits, not actual benefits. This is due to the fact that the benefits are implied, not directly estimated. Let's see how it works for this example. Here is the relation for delta B, the incremental benefits. It was introduced earlier. The usage row, shown here, is taken from the table of estimates. G, the defender, has an annual usage level of $960,000. H is higher at $1 million. Therefore, the present worth value will be negative. Since challenger H has an incrementally negative benefit of over $415,000, it can be eliminated immediately, and G remains the defender. The second and last comparison is J versus G. Now defender G has a larger usage bill than J, that is $960,000 versus $550,000 for J, shown here in the estimate table. The present worth of $4.256 million is the incremental benefit of J over G. Step 4 is for direct benefits only. Since the benefits are implied, we skip step 4. We need the remaining incremental values for disbenefits and costs to complete the J versus G comparison. This table shows the estimates for G and J only, since alternative H is gone. The two shaded rows are used to determine delta D for disbenefits and delta C for costs, respectively. Incremental disbenefit is the difference in present worth of backup costs. That is $950,000 for J minus $650,000 for G. This is a total of $300,000 or 0.3 million. Delta cost is the present worth of cost difference, which is shown here as $3.231 million. We have already determined the delta B value in step 3 on the previous page as $4.256 million. The incremental BC ratio is delta B minus delta D divided by delta C to get 1.22. This is greater than 1. Therefore, we eliminate G and select J as the best option economically. A couple of final remarks about the incremental BC method are in order. When the mutually exclusive alternatives have very long lives, the capitalized cost relation is used to find the AW or PW equivalents for B, C, and D. This relation is the same derived in your text and in an earlier presentation. It is AW is equal to present worth times I for the AW amount, or solving for present worth, it is AW divided by I. Independent projects do not require incremental BC evaluation. Therefore, when the total BC ratio of each project is greater than 1, the project is selected. This assumes no budget restrictions are present. That's the end of the presentation. Thanks for watching, and I hope you have a great day.